Welcome and thank you all for joining us today for our webinar, Ditch the Ditch, Deploy Broadband Faster and Cheaper with Altowave's Wireless Advantage. Here to present from Altowave is our VP of Sales, Melvin Gallardo. If anyone has any questions throughout the presentation, please feel free to add them into the chat and they'll be addressed at the end of the session. Melvin, you're up.
Thank you, Dawn. Appreciate the introduction. Thank you guys for joining me today, this afternoon, to talk a little bit about Altowave, how we can help them to do cheaper deployments and much better, much efficient deployments using wireless. And it's not just about wireless itself. We'll be talking a little bit about how you can use other technologies in addition to fixed wireless to do a much better hybrid networks. A little bit about the content here. I will be talking definitely about who am I, just a little bit who Altowave is, and what connectivity options do you have besides fiber. Everybody's talking about fibers, the beautiful options that you have with fiber, how you can grow, but it's very limited also in options when you don't have the resources to deploy fiber. How mmWave technology can help you, how the BEAD updates program could also help you to deploy a much better networks that allow you to grow way faster and better, how the hybrid technology and application for broadband can help you, how you can use all those technologies about CBRS, what is good for CBRS, what is better on or not on mmWave, how you can use also fixed wireless on 6 gigahertz in combination as a hybrid network with those. We'll be talking briefly about our products, how our products can help you to deploy those networks, what services do we offer as Altowave, what kind of broadband applications are ideal for mmWave. We'll be talking a little bit about our case studies with QuidBit Internet and a good starter kit that we have through Winncom. And we will have a section for questions and answers at the end. A little bit about Altowave. Altowave, it could be a new name for many of you. Altowave was renamed from QuidBit Networks last year. The main reason why we did that is because QuidBit has a spin-off company called QuidBit Internet, which is a broadband internet service provider, completely wireless, completely mmWave, that are growing exponentially, serving a niche market of mobile homes using mmWave, and we don't want customers to confuse between the ISP provider and the manufacturer side. We are manufacturing all the equipment, or the majority of the equipment in US. We're made in US. Our engineers are in US. Our support and pre and post sales support is here in US as well. We have 2 offices, one in Minneapolis and one in Waseca, Minnesota. We have sales team through the country, and all the support is here in the States. We have been manufacturing products since 2012. We used to use LTE 4G technology in the past. We migrated to 60 gigahertz in 2016. We're using right now our 4th generation of 60 gigahertz product. Basically, 60 gigahertz and mmWave is a pretty mature product right now that would allow you to overcome so many limitations in the past and also overcome speed capacities that the technology is good for. When we talk about connectivity options, I try to put everything in a little table that show you what's the pros and the cons when you are trying to use. Obviously, fiber allow you to go very long distances. It has a multi-gigabit capacity. You can grow from either 1 gigabit all the way to 100 gigabits. It's definitely expensive. It's time consuming. It's limited by whether you have to do subterranean, you have to do trenching, and you have to get permits, and it's expensive. And that's why it has limited the availability to expand the broadband and the BEAD program to go everywhere as it was expected, serve the underserved communities way faster than it has been done. How now that BEAD have changed in the way that this technology neutrality, and you can use other technologies besides fiber to go after broadband underserved customers, underserved communities, how you can do it. Can you do a sub 5 gigahertz or sub 6 gigahertz and 6 gigahertz fixed wireless? Definitely you could, but obviously those technologies are more prompt to be able to hack, they're limited capacity, and the capacity doesn't have anything to do with equipment, right? The capacity is limited by the channel size that you have available. You only have 160 megahertz in the best case available for you to use. They're definitely a low cost compared with other technologies. You will have a high latency because all the competition that you have trying to use those channels or the same channels, it happened in the past. 5 gigahertz is definitely super crowded, super busy. It's really, really difficult to deploy anything in 5 gigahertz. Now the 6 gigahertz frequency open it up. It helps a little bit, but we don't know for how long those channels could be clean and available to use and deploy. And then it will happen again, the high interference and high latency and the interference that goes all together, right? The capacity, the latency, and the interference goes together. You don't do anything with equipment that's supposed to support your 1.6 gig. If with the noise and interference, you're only going to get 100, 120 meg when you are trying to support hundreds of customers, right? But definitely it's fast time to market. What other options are available right now? There are fantastic companies out there like Tarana they're doing an incredible job trying to do and deploy CBRS and 6 gigahertz. Definitely it's a market that allow you to go to no line of sight or near line of sight applications that definitely allow you to go in a pretty dense area or less dense areas with trees and obstacles in between to be able to get signal to those, which was a limitation for fixed wireless before. The line of sight always been an issue with technologies like CBRS allow you to go to those applications much better, but it's limited to the frequency availability. Depends on regions, right? Depends on location. If you're close to areas where there are no PAL license available, it's just TAA, and TAA is very limited, then you will have problems with the equipment. And again, it's nothing about the equipment, it's availability of the frequency. What are all the options you may have available on fixed wireless to deploy a fast, reliable, and effective deployments using fixed wireless? That's when millimeter wave comes in place. Also, millimeter wave is not perfect in any sense in the way that millimeter wave is limited by the size of the coverage of the signal. Obviously, is the fastest possible capacity that you could be able to get in a fixed wireless by point-to-multipoint. It has a multi-gigabit capacity, definitely affordable, way lower cost than fiber deployments, faster deployments because you only need to set up the tower, put the equipment, the distribution node, and start broadcasting. It's a free license. 60 gigahertz is a free license to use in the United States. Everywhere, you have the full usage from channel 1 to channel 6 to use as a license free. It's very low latency. It's a beamforming, which is ideal for any BEAD application that the equipment on the fixed wireless support beamforming. All of our equipment support beamforming, and it's reliable. It's immune to interference because the beamforming and because the super low usage of the 60 gigahertz as a frequency itself. If you are not very familiar with 60 gigahertz or how millimeter wave frequencies are, I just put a little chart here that gives you an idea and a scale in comparison of all the frequencies in the whole FCC spectrum with sub 6 gigahertz and the new slightly spectrums that we have from 6.0 to 6.4. And then the sub 6 frequencies, as you could see, is very tiny in sense of channel available compared with 60 gigahertz. What is called millimeter wave as a technology includes two different bands, frequency range. One is a V band, which is a point-to-multipoint, and one is E band. E band is semi-licensed, or what we call semi-licensed or light licensing. You only need to register your links. It's only for point-to-point. It's only for full duplex equipment. and it goes all the way from 71 to 95. Most of the equipment support right now between 71 to 88 or so. But the frequency defining itself, it goes all the way to 95. 60 gigahertz support from 57 gigahertz up to 71. And you have a bunch of channels here that each channel you support 2000 megahertz. In comparison with sub-6 or CBRS are very tiny channels. CBRS, you only have channels around 40 megahertz, the best case. And you can use multiple channels of those as a co-channeling. But in 60 gigahertz, you have 2000 megahertz. Keep in mind, in the best case of 6 gigahertz, you have 160 megahertz channel size. Means by size, by channel, you have a lot. You have 2000 megahertz of channels available per channel. You have up to 6 channels. And obviously, a lot of customers ask, hey, what about the rain fade on those high channels? Definitely, that's something that's physics. We cannot do anything against that under the lower channels. That's why the capacity in terms of distance is shorter than the lower channels. That's why channel 1 through 4, you could see distances that goes up to 1,300 feet, and channel 5 and 6 that increase the capacity and distances up to 5 miles or so. Means now 60 gigahertz could allow you to have long distance links with super high capacity in a low interference environment with beamforming for point-to-multipoint. On the E-band, it's ideal to use on the edge of the network because it allows you to have on the same 2000 megahertz channel size, you can have 10 gigabit full duplex, and now some brands are coming out with dual channel or XPEC that support up to 20 gigabits of full duplex capacity in E-band. Again, E-band require you to register your link with the FCC, but that's definitely an option that could replace the fiber or allow you to do a quick deployments while the fiber gets completed in those locations or those towers. When we talk a little bit now with the new BEAD updates, I don't want to get too much into the regulation itself because it's sometimes pretty overwhelmed in all those forms and all the stuff. But in main concept is now open it up to other technologies besides fiber as a favorite technology in the past. And again, I don't have anything against fiber. It's just slow deployments. It's just slow deployments. You cannot do as fast as you would like. It's expensive. In many places, it's underused. I mean, there's other technologies that could complement the use of fiber and other technologies to go faster, better, quicker. As I now allow you in the BEADs to use technology neutrality, you can use fixed wireless in addition to fiber to go after customers and after communities underserved. And again, sometimes people associate the BEADs as a rural community. It's not just rural, it's underserved. And there's so many communities on the cities that are underserved. I mean, they don't have a carrier going after those communities. We are seeing that, and I will show you on the case study that we had, that we are going after helping mobile home communities to get access to internet or broadband in a way that they never saw before because they didn't have the option before. The carriers doesn't go after that. They are underserved community. Most of them are, some of them, or the majority of them are low income. Then it's really hard to get service. Then with our help and our way to do deployments, it helps a lot and it helps in a great way because offer them capacities up to a gigabit per home. Then if we think about fiber, obviously fiber always would be there. I mean, we want to work with that. We want to use it. We need it, right? We need fiber on the edges. We need fiber when it's available. And then we can use it in combination with the fixed wireless, either 6 gigahertz, CBRS. Again, CBRS is a great technology that allows you to go and get signal to the no line of sight places where either trees or interference or buildings doesn't allow you to go with other technologies besides CBRS. Again, how can you use, I'm going to put a few cases here, how you can use a hybrid deployment in scenarios where you can do a perfect deployment, super fast, gigabit capacity, being able to support the 100 by 20, which 100 by 20 would be pretty much nothing and will be at least the minimal that you can get to get those deployments. In our equipments, the capacity is symmetrical, means you will be able to get as much as 1.9 gigabit through the network shared between all the devices connected. And the new technology and the new protocols allow us to have a higher density in the equipment to be able to share that capacity between on the point-to-multipoint. When we talk about hybrid technologies, what we can use, ideally, obviously, fiber everywhere would be nice, but when you only have fiber coming into the tower or fiber coming into the water tank or fiber coming into the silos, how can I use other technologies to help me out? Okay, if you have fiber coming in on the tower, or maybe even because the fiber is not available there, and you have a location with fiber, which is between 1 to 3 or 4 miles away, you can effectively use EVAN to get a high capacity 10 gigabits link to those towers. Well, if you have fiber, even better. If you have both, even better, because you have a redundant capacity, you have resiliency on the tower, and you have also a backup links in any case that the fiber get lost or to lose the power for any reason. Then from the tower, which is your edge, to goes to those communities, you can do CBRS, you can do 6 gigahertz, you can do 60 gigahertz long range to go to either the water towers, the silos that get closer to the communities and be able to serve as many people as possible. Then if we go from the water tower, which we consider the edge of the town, then you can have 60 gigahertz. Again, depends on the elevation, depends on the line of sight, depends on the fiber availability. You can have either any of those technologies in addition to the fiber, or together with the fiber to help you out to get the majority of the capacity. Means if you have a range between 5 miles, you can use a long range 60 gigahertz with 2.3 gigabit capacity to go to the communities hubs to be able to support as many customers and spread that signal either on MDUs, either townhouse with multifamilies, or either single families application. It's in that way you can have a pretty nice coverage. And again, the main purpose of doing an application like this is don't lose your capacity through the hubs. 60 gigahertz, a millimeter wave allow you to have a pretty high capacity network by wireless that when you go through hubs or through connections, you don't lose that capacity, right? Either because distance, because interference, because noise, because all the things that could apply to the wireless links. In this way, you can use a multiple hybrid applications to go at the end to as many customers as possible, serving with high capacity. Now 60 gigahertz allow you to go, depends on the technology, on the protocols that you use. You can use up to 32 customers by a single distribution node. That's allow a pretty high density. Obviously, the density is a double knife, right? A double edge. I mean, higher the density, lower the capacity that you will have per customer, because the capacity that you're sharing will depend on all those. But if you consider the concurrency on all the capacities, it's still pretty high. And it will be always higher than 6 gigahertz. It will be always higher than CBRS or any other technology on the point-to-multipoint, because it's the fastest possible capacity that you can have as a wireless. When we goes in details into product itself, as an Altowav, we provide a variety of products, depends on the capacity, depends on distance, depends on density, depends on the application itself. We have a whole line of product in 60 gigahertz that goes from our K60 that is mainly designed for smart cities and security applications and schools deployments more than broadband, because the higher density in the equipment, the K60 only allow you 8 remotes per distribution node, means it's based on 802.11ad technology or protocols. Now the Altoplex series and the AltoReach for long range allow you to have way higher density, but also way higher capacity. The Altoplex is the fastest equipment that you can get in the market in 60 gigahertz, support up to 3.8 gigabits of aggregated capacity. But if you think about broadband, you want to talk about aggregated capacity. Many people call that as a marketing. In reality, you can get 1.9 gigabit symmetrical, which is important for you because that's a full capacity that you will be able to share as a download for all your customers. And obviously, because it's symmetrical, you will be able to get the same capacity both ways. Means the 120 minimum requirement by BEAD, you definitely should be able to overpass that capacity by a lot using an equipment that support 1.9 gigabit to share. Altoplex support 1 to 16 devices, which one of them could be another distribution node that will be able to rebroadcast the signal if needed. Just depends on the application installation itself, but you will be able to support 16 per single distribution node. Distribution nodes are 90 degrees. Basically, those 90 degrees, you will be able to have 16 by 90 degrees. Means if you are in a pole or in a tower where you're supporting in a single channel or in a 2 channels used 360 degrees, you will be able to support up to 64 clients per a single deployment. The beauty of 60 gigahertz is because it's beamforming and low interference, you can have multiples of those channels on the channel reuse patterns to use multiples access points going on the distribution nodes going on the same way without causing any interference at all. Means in a single tower, you should be able to support a couple hundreds of devices without much interference between them. Altoplex support 4 channels. AltoReach is using a different chipset that support up to 6 channels. That's why you can go long distance on channel 5 and channel 6 and 60 gigahertz. The main reason, again, is physics. Channel 5 and channel 6 doesn't have oxygen absorption. That's what allows you to have way more distance out of the same kind of equipment using the same channel size. It's a 2.3 gigabit capacity to be able to share as an aggregated. It's point-to-multipoint, support up to 32 remotes. Again, we don't want to use the full capacity of the remotes because that would be reducing the capacity per single device. But again, depends on the number of devices, the concurrency into the access point that will be supporting that. The AltoReach, by being a long range 60 gigahertz, people have the concern about, hey, what about the range rate? What about if I have a torrential rain that pass within 5 miles range? What can you do to avoid any interruptions? Then that's why we incorporate into the device a 5 to 7 gigahertz backup radio. Means the radio will be automatically switched to the backup radio in any torrential rain or any rain that reduce the capacity of the radio to a minimum that you can determine to do the switch, and then the equipment will come back in 60 gigahertz as soon as the event passes. Is 256 bit encryption that add the security on those. We also have another 2 devices that is more into the point-to-point besides point-to-multipoint. It's a 5 gigahertz point-to-point that is, again, it's more designed for all the applications that broadband. And we have the Alto link, which is 80 gigahertz, which is just a fantastic super fast radio that support more than 10 gigabit full duplex or 10 gigabit full duplex to do E-band 80 gigahertz on the edge. That would be perfect and ideal when you need to provide a 10 gigabit capacity to one of your silos, towers, water towers, or be on the edge of the community to be able to get that high capacity, sometimes even better than the fiber for those areas that need support, very quick deployments, FCC registrations, very low cost, you only pay one time for 10 years license. The benefits of using Altoplex on the 60 gigahertz, what it makes us different with other manufacturers is, besides we're using the latest protocol, which is 802.11ay, that allows you to have that fastest capacity possible, better than other manufacturers are still using AD. We're using a completely decentralized architecture. We don't use a controller in order to provision the radios or commissioning the radios. Our radios are completely layer 2. You only need the IP address to manage the radios. Altoplex and AltoReach could be managed by Wi-Fi. Basically, you just access the radio remotely to configure the radio. You don't even need to plug into it. And one benefit that we offer that no other manufacturer offers is provide an open API. Basically, if you are in a network that you're using a hybrid application where you have a fiber, where you have a CBRS radio, you're using Tarana, you're using Ubiquiti or Cambion into the 6 gigahertz, and you would like to use Altoplex into the 60 gigahertz or the 7080, you could do it. I will be able to provide you the open API for managing the radio. Means you don't need to get our network management system or force you to use our network management system in order for you to control your radio. We'll provide you that for free, that you can integrate with any of your network management system that allow you to use APIs for managing other radios or other brands. The Altoplex line includes a multiple radios. The main reason is because not all the radios need to support the full capacity. The D621 could be used for distribution node or remote. All the radios are 90 degrees. All the radios are using 2 tiles, 128 elements antennas, or the D621s. And the C420s and 410s are mostly designed for remotes. When on the remotes, you might not need more than a gigabit capacity. You will have a gigabit full duplex in those, and depends on the distance, will be the 2 tile or 1 tile. That's why wirelessly you have the same capacity, but the 2 tiles or 1 tile allow you to have better modulation to a longer distance. That's why the 420 is get more distance with more capacity, and it's lower cost. I mean, the main idea is to reduce the cost on the remotes to be able for you to deploy a cheaper way to have a gigabit capacity to the homes. That's why we have been able to do it to our sister company into the mobile homes communities to go lower cost and affordable with a gigabit capacity. The D423 is part of the same line of products. I actually have one here on my hands. As you can see, the radio is very tiny compared with my cell phone. It's very tiny, the radio. It has 3 ports that basically have 1 PoE in, 2 PoE outs. That will be giving you the benefit to plug in directly a Wi-Fi device, plug in another radio, or plug in a camera. Who knows? I mean, or plug in an IoT device. Any device that may need power without using a switch or an IMA port box is ideal for this radio. And in the presentation, you will see a couple of characteristics of the D621, the 410 and the 420, the ability to have a GPS co-location that will be provided to you either as a SNMP that is also supported by our radio or through the API to give you location, and it's also used when you use synchronization to reduce interference between co-channeling. It's using Wi-Fi for management. In this case, it's a single port for the D621. We don't have a 360 degrees radio just by the fact that after analyzing in so many ways, typically it's really hard to find everything on the same level without elevations difference. And we do a lot of deployments on security applications and cities, like New York City, so you have elevation difference between poles and buildings and so on. Then if you have a 360-degree radio, you cannot change the height or the elevation per sector. In our case, we have a single mounting bracket that may allow you to mount 4 radios, and then you can play on the elevations for those radios as well. Okay, Alto Reach Long Range is our product that is actually coming out very quickly. Is again, we designed it to be 5 kilometers or 3 miles effectively. We're looking for high capacity. We're not looking for distance. Distance-wise, could go more than that. By the fact that you have a 5 gigahertz backup, you will be able to get even more distance than that. Okay, but in our case, we want to market the product as a high capacity. If you want to have a product high capacity, obviously the distance will be a factor on that. That's why we're marketing the products at 3.2 miles with high capacity 2.3 gig, supporting 90 degrees into the main unit, and then the remote will be able to support 6 degrees, 5 degree up and down for connectivity. Very easier to align than other technologies, other equipments, and also the backup will be able to support in case of those frame fade that could be affecting the 60 gigahertz links. For customers who want to have our complete suite of products, we also have a network management system that works with all of our products, either the 80 gigahertz, the 5 gigahertz, the 60 gigahertz, the long range, the normal range, called Alto Command. Alto Command is a complete suite that is on the cloud as a virtual server machine, or is also on premise, depends on how you want it. And also you get the same information that you get on the Alto Command, you will also get it on the API. You will be able to have a network status, the map view with the GPS location provided by the radio. You will be able to do device configuration, device upgrades, analytics. The equipment of the Alto Command will be able to do AI support in the future to provide information and also fix the problems when they happen to a specific frequency with noise interference. The radio will be able to switch by itself to a better channel if it's available without needing to do that switch manually. Means the Alto Command would be smart in the way that will be able to help you as a provider to help in those cases that the signal is affected by any of those incidents, events into the link. When we think about applications for millimeter wave, again, millimeter wave is limited by distance, is limited by line of sight. 60 gigahertz require line of sight. And sometimes people say, well, line of sight is hard to get. It's not that hard. I mean, when you are a higher frequency, because the wavelength is pretty tiny, the Fresnel zone is way smaller than a lower frequency. If you go to 365, or you go to 5 gigahertz or the 2.4, the Fresnel zone is quite big compared with 60 gigahertz. I mean, 60 gigahertz, technically, you can see it, you can shoot it. Obviously, it doesn't go to trees, it doesn't go to buildings, but you can deploy a pretty good deployment with a clear view of the links. Like a garden style communities, manufactured homes communities are a big one. Believe it or not, there are more than 25 million people living in manufactured home communities. RV parks, office parks, MDUs, or multi-dwelling units are a big one in high density cities. Cities like New York, like Los Angeles, like Chicago. Many of those cities are ideal for 60 gigahertz. By the fact that 6 gigahertz and 5 gigahertz is overcrowded, CBRS is really hard to get in those areas by being close to the coast. And then 60 gigahertz is your best alternative to get that. Obviously, in most of those cities, they have already pretty good layout of fiber, but you can also serve in areas with the new construction or new deployments pretty quickly using a mmWave. By the fact that you will have a high capacity coming in into buildings and then share that capacity internally through switches and so on. Smart City is a big also into mmWave. We have been deploying and keeping deploying a lot of applications using police departments for video surveillance and also to provide Wi-Fi to parks and recreation departments. Let me talk a little bit about this case study again. Quickbit Internet is our also a sister company, even though they are completely separated now. Quickbit Internet, it has a niche market to serve mobile homes communities. And again, mobile homes have always been underserved. It's been usually typically seen as low-income families, but in reality, it's a community that is growing, and it's a great alternative to have a low living cost expenses. But at the same time, everybody right now needs to be able to find a house, a home where part of the utilities is internet access. I mean, really now, right now, it's kind of hard to move somewhere where the internet may not be available. You may not have TV. You may not need TV. You don't need cable TV. You may not need a pool or other amenities, but for sure you need power and you need internet. I mean, everybody depending on rely on the internet. You have kids even more. It's Altoplex. We deploy Altoplex. Or Altoplex is the only equipment that Quickbit networks use. Moving forward, they use the first deployments, they use it with the K60. This is your typical application. They come with the community with either they have fiber into the community or either they have high capacity link into the community to get the on the edge or somewhere close to the community where they can have at least a gigabit. They don't serve any community. They cannot get a gigabit as a main backbone to the community as an internet capacity, and then they spread the signal through the community to be able to serve the complete community. When the community depends on the deployments, some of them use it as utility that they just added into the rent. Some of them are by option. I mean, the customer could get a cable company or a carrier, or they can use cellular, or they can use LTE, or they can use Altoplex and stuff. For Altoplex, they require an equipment for each mobile home. In this case, for Sierra Vista in Arizona, they have fiber is coming in into the edge of the community, and then they deploy all the distribution nodes in a way that they can support a gigabit per home. This is all the distribution nodes, and as you could see, they're able to support every single house. Obviously, not all the houses get signed up at the same time. Some of them has a 30, 40, or 50% of signups. They have some communities that they require 100% of the signups because that's the way how they contract those specific communities, and those are great because they can give you a guarantee access on all of them. But even on communities that have 30 or 40% access, they are sure that they have coverage through the whole community. Like in this case, this is a already contracted community, and they're going after the next one, actually using the same capacity of the fiber that could be increased up to 10 gigabits and then shoot to the other community and keep spreading the signal and sharing the capacity and the broadband to the next community. I mean, this is a way that in other cases, maybe by the old BEADs being an underserved community, they will try and they must do fiber per home. And in that case, they will use technologies to allow you to do that. But just imagine the cost to go to each of these locations using fiber and the time. With this one, the cost is way reduced, communities can afford it, and they can have a super fast, reliable internet access. As a professional services, we offer the whole certification and training for our customers. We do the wireless network designs for you. In this case, we have another community that shows here that it is want to provide internet to their tenants. They have about 361 through the community. We did the full design coming in from the main office where they have fiber coming in, and they don't have any other options besides cellular. Cellular is the only option that those owners has as an internet broadband access. And then we did the whole design, being able to provide access to 361 homes coming from a single fiber, and the whole cost of providing the full access. I'm talking about the cost of our equipment, with including the distribution nodes, all the power and all the equipment, doesn't get to $250,000 for 361 homes. Means it's very affordable when you consider the return of investment. It will be pretty quickly, and also the deployment time, it will be very, very fast. And with our equipment using all those hubs and rebroadcasting the signal, we'll be able to provide a gigabit capacity per home. Obviously, when you're talking about gigabit capacity, you're talking about 1.9 gigabit on the distribution node to be shared up to 16 devices. If you make the numbers, typically goes 100 by 100. If all of them, if you have 100% of concurrency by the distribution node. We do offer technical support, again, here in the States, and pre and post-sale support. Our support team is in Minneapolis, Minnesota. We offer on-site support per requirement basis, means we can go on site, we can do the site survey for you. It has a cost, and in all of our bill of materials, we include your extended warranty as a peace of mind for you as a customer. If the customer needs to support or being supported after a year manufacturer warranty, you will have that option as well. Winncom has a pretty nice starter kit promotion that we are doing with them, and be able to support 3 equipments. Basically, you have a D621, it's a distribution node, and you have 2 C420 long range devices that will be able to support you through 1.9 gig, shared between 2 of them, all the PA injectors with a pretty good discount, about $13.99. That will include the 3 devices. Again, you're talking about a super high capacity device. You have a lower cost device on the C410, but we want you to experience the long range, high capacity with the 420. The 410 is a lower cost unit for shorter range, and again, everything will depends on the kind of applications and developments that you do. If you are in distances from the base station that are within less than 500 feet, you can use a 410 the C410 at any time with pretty high capacity and speed. And there is a link on the promo on the slide for you to access directly, and that will be complete my presentation.
Wonderful. Melvin, we do have a couple questions on doc. I'll start with the first one for you. Can you provide your thoughts regarding the future of CBRS and 6 gigahertz with the new FCC mandate to auction off 700 megahertz in the next 2 years?
That's a great question. That's actually a fantastic question. I mean, from my own point of view, I'm being in this field for 25 years, and I think CBRS was not as it was expected. I think it was a lot of noise and a lot of excitement when CBRS came out, but the deployment of the CBRS with the different DePALs and the GAAs, it was kind of difficult, the competition, and to try to get some available space on CBRS. Obviously, equipment like Tarana with a fantastic technology that they use helps to get more capacity through the limited of channels on CBRS, because that's the issue. It's limited on capacity, it's limited on channels. you cannot get more channels. I mean, you cannot tell the Navy, hey, don't use your channels, or you cannot tell the PALs that are not using the frequencies, give it to me. I mean, that's a limitation itself on CBRS. At 6 gigahertz, again, it's a fantastic technology. It increased the capacity of 160 megahertz that allow you to have gigabit capacity into those unlicensed 6 gigahertz. How long that will last? I mean, we have seen in the past. I mean, as soon as the channel gets available, everybody migrates to use 6 gigahertz. And then what? What you're gonna do is now the equipments are way more smarter than before, more resilient against interference. You have beamforming that definitely helps, but it's a matter of time. I mean, if you keep using it and using the same channels, we will have the same problems at 5 gigahertz. And chances are that I think uh, my view of the future is that FCC allow you to have other frequencies that they are opening it up to be able to use point-to-multipoint with a clear and better channels available. I hope that answers your question.
Very nice. And one more for you. What Altowav radios are capable of 1+ mile point-to-multipoint? I'm only seeing 400 meter max.
Correct. I mean, Alto Reach is capable to do 1.6 miles on point-to-multipoint. Alto Reach, when you do a combination between the distribution node and the remote. If you're using a point-to-point, you can do up to 3.2 miles. But on the point-to-multipoint, you can use up to 1.6 miles. Technically, we'll be able to get more than that, but again, we're trying to be realistic with our capacity. We want to be able to provide a high capacity with a realistic range. We don't want to make the same mistake as other manufacturers that tell you you can go 8 miles. But in reality, yeah, you can go 8 miles, but it won't be on 60 gigahertz. It will be relying on 5 gigahertz all the time. It's 1.6 on the Alto Reach.
Very nice. Well, thank you, Melvin. That concludes our questions.
Thank you very much. I appreciate your time.
Yes, sir. And as a quick reminder to our listeners, we'll be sending out an email shortly with all this information you just learned, as well as the link to the current starter kit promotion. So please keep an eye out for that. I hope you all have a wonderful rest of the day. And as always, thank you for joining.
Thank you very much. I appreciate it.
Thank you.